Hi there, intermediate algebra students. Time for a pretty short little lesson here, factoring the difference of squares. This is one of those polynomials that we again looked at last chapter, but we primarily looked at multiplying a couple of binomials to get this. But now again we'll look at factoring or breaking them apart. So again, here's a key here on this little poster, being on the lookout for two perfect squares and a minus sign. So as you can see, x squared minus 36, and what that's going to be factored into. So let's get right. We can figure out here some examples here. So we'll get right to it. Each of these is really a difference of squares. And so really you're going to try to find the square root, or what is it that is multiplied by itself to make this a perfect square. Still look for common factors. We don't see any. So then I make my two sets of parentheses here, of course. And it's going to be x and x. And then the square root of 25 is 5, so 5 and 5. And one sign is minus and one is plus. And sure enough, if we FOILed this out again, or use that MAM method, we would see that in this case that middle term would cancel out and we would get x squared minus 25. Alright, let's look at another one here. Next one. Yeah, no perfect squares here, so then I make my sets of parentheses, and sure enough it's going to be 4q and 4q that goes there. Square root of 49r squared is 7r and 7r, and then we have one minus sign and one plus sign. Now last one is a little trickier here. Because of these exponents, it looks a little strange. You don't think of a 6 or an 8 as a perfect square, but sure enough it can be. No common factors here. So what is the square root of 8 to the 6th, or what value would I have to multiply by itself to get that? Well, sure enough it's going to be 8 to the 3rd times 8 to the 3rd. Remember, we add those exponents to get 8 to the 6th. And then the square root of 81, of course, is 9, so that goes here and here. And then z to the 8th, well, we're going to use z to the 4th for my exponent, because z to the 4th times z to the 4th is z to the 8th. Minus sign, plus sign. Doesn't matter the order that you put that minus and plus sign, but there's the factored form right there. Now occasionally what might happen is, even when you do the first factoring, maybe one of these factors ends up to also be a difference of squares, which you can further factor down. We'll probably see some of those in class as we go on. Now, but here's a good example of how you might use this difference of squares idea here. So we have, see if we can find the product of 28 and 32 mentally. That means without a calculator or anything. So they're both pretty close to 30. So 28 is in fact 30 minus 2, and 32 of course is 30 plus 2. So sure enough, there's my difference of squares right here. I could FOIL this out a little bit, and I know that 30 times 30 is 900, and 2 times 2 is 4. So really I'll end up with 900 minus 4, which is 896. So that's a quick way of multiplying some numbers that are kind of close to each other using that difference of squares idea. Alright, so that's about it. Pretty short little lesson here, and we'll continue to work on this in class, so keep plugging away with this factoring stuff. See you guys then.